Assalamu alaikum wa rahmatullahi wa barakatuh. To conclude our topic related to fertilizers, we're looking at an exam question, and this particular question was taken from the March 2011 paper, if I'm not mistaken. I will just double check that for us. 1 second. March 2010 paper. Okay, so this was taken from the March 2010 paper, and we will look at it uh, and see how a typical exam question related to fertilizers is asked. Okay, so to begin with, question 1 says, write down the name of the industrial process in step 1 used to extract nitrogen gas from the atmosphere. So the extraction of nitrogen gas, 12.1, takes place by the fractional distillation of liquid A. In liquid form, liquid A basically. How does A become a liquid? As we discussed, the A is cooled down to minus 178 degrees Celsius or even more. And as a result, when it liquefies, then we fractionally take out nitrogen at a different temperature from oxygen. Okay, so fractional distillation of liquid A is the answer. 12.2, the Haber process indicated in step 1 is represented by the following. H2 plus N2 gives you 2NH3. Delta H is less than 0. That means the forward reaction is exothermic. In this process, high temperature of approximately 450 degrees Celsius are used. Explain in terms of the reaction rate, equilibrium, and temperature why such a high temperature and not a low temperature is used. Okay, if the forward reaction is exothermic, then we can say a decrease in temperature favors the decrease in temperature favors the exothermic reaction. So, logically, it means that if we cool this reaction down, more ammonia will be made. However, we see that this reaction is very slow, because if the temperature is low, then there's less kinetic energy and there's less effective collisions, and as a result, this reaction is very slow. So, in order for you to increase the yield, because you are a businessman and you want to make more ammonia, because more ammonia means more products, which means more business, therefore, a high temperature is more favorable. A very high temperature is more favorable because it creates a higher yield. Is more favorable because it creates a higher yield. Is more favorable. Favorable because it creates a higher yield. More favorable as it makes more products. Okay, something to that effect. It's 12.2. Numbering is very important. 12.3. Write the balanced chemical equation for the reaction that produces nitrogen fertilizer in step 4. And we've discussed something similar to this in the past years. Step 4, we have a nitrogen fertilizer. Now, what are the chemicals that are reacting? We see that yes, NH3 and there's nitric acid, which is HNO3. So we can say NH3 plus H ammonia plus nitric acid makes NH4 and O3, ammonium nitrate. Okay, let's see what they ask for. They ask for a balance equation. Is this equation balanced? This one nitrogen, four hydrogens, nitrogen. So it's balanced. So that is the reaction that takes place. They may ask you what is the formula of the chemical. Then we say NH4, NH3, NO3. They ask you for the name. Then we say ammonium nitrate. So it's very important to answer exactly what they are asking for. 12.4. The learner decides to educate the community about the possible negative effects of the overuse of nitrogen fertilizers in the environment. Write down the main arguments that she will raise to convince the community to avoid excessive use of fertilizer. Yes, we've answered this something similar before. She can talk about eutrophication. Eutrophication, I spelled it wrong. Spelling is always my problem. Eutrophication. Eutrophication is one option. Eutrophication. She can talk about blue baby syndrome. Blue baby syndrome. She can talk of contamination of excess nitrogen in the soil that causes carcinogens, which cancer risk due to contamination, etc., etc. So those are the answers that she can give to answer question 12.4. 12.5. The learner notes that fertilizers with an NPK ratio of 7:1:1 is needed for the growth of a maize plant. We've discussed this question before, so I just wanted to mention an additional aspect, something that I haven't mentioned earlier. 7:1:1. So sometimes you can get a case where they will tell us, okay, the ratio of the NPK ratio is 7:1:1, and they put something in brackets. So they say 30, and they say calculate the percentage of nitrogen, phosphorus, and potassium in this fertilizer. Now the 30 will refer to the percentage of pure fertilizer. That means only 30% of this fertilizer has the active ingredients. The others are filler, whatever the case may be. So what percentage is nitrogen? So nitrogen percentage of nitrogen will be, in terms of this, if we look at it carefully, we see that 7, 8, 9 of the 9 parts, 7 of the 9 parts, 7 parts is nitrogen, 1 part is, let's just write this down, N, P. Okay, 7 parts is nitrogen, 1 part is phosphorus, 1 part is potassium. So 7 of the 9 parts is nitrogen, and then you times this by 30, and that will give us the percentage. And 1 of the 9 parts will be the percentage of phosphorus, and the percentage of potassium is 1 of the 9 parts times 30. So if you take our calculator, we say 7 divided by 9 multiplied by 30, which gives us 23.3%. And this one will give us, if we cancel this, 1 divided by 9 times 30, and 3.3% will be potassium and phosphorus. So this is an important aspect. So this is a typical example of the type of question that you can expect at the end of the year. Good luck with the final exam.